Good morning, students.
Good morning, sir.
Write your name and roll number in the chat box. Anyone tell me screen is visible to all?
Yes, sir.
Yes, sir.
Neeta Chaudhary, mute yourself. Pallavi, चव्हाण पल्लवी, आवाज येतोय का? पल्लवी चव्हाण, पल्लवी आवाज येतोय का माझा? तुझा आवाज येत नाहीये आम्हाला. आविष्कार आवाज येतोय?
येतोय ना सर.
आता येतोय का बघ बर?
येतोय की.
ओके, ठीक. सुरू करू. ऑलरेडी 8 वाजून 2 मिनिटं झालेली आहेत आणि 40 स्टुडंट्स आर जॉईंड. So in the last lecture we had discussed about this addition reactions, addition of hydrogen halides, Makovnikovs rule and anti-Makovnikovs rule. These rules are very important, remember, for the 12th standard examination. When the unsymmetrical reagent, see this is unsymmetrical reagent and this is unsymmetrical alkene. When this type of conditions are there, unsymmetrical reagents gets added to the unsymmetrical alkene, then this negative part, always we have to check the negative part. Always there may be bromine, there may be chlorine, or there may be iodine. So these negative parts gets attached to the carbon atom, which is having less number of carbon atom, that is the major product. This statement is given by the scientist Makovnikov's rule. So according to this Makovnikov's rule, here 2-bromopropane, or the common name is isopropyl bromide, it is the major product. The common name of this compound is 2-bromopropane. And opposite to this Makovnikov's rule, there is a one rule, it is called as anti-Makovnikov's rule. It is also called as Kharash-Mayo effect. Again, these are the name of the scientist. And it is also called as peroxide effect. Peroxide effect because the peroxide is used, and this effect is shown only by HBr, remember. I'm going to underline this HBr, remember, because peroxide effect is shown only by this HBr. If HCl is added or HI is added, always the addition takes place according to the Makovnikov's rule. In presence of HBr also, remember, in presence of HBr also, HCl and HI undergoes Makovnikov's addition. Only HBr undergoes anti-Makovnikov's addition, means when HBr is added, the negative part of the reagent gets attached to the carbon atom which contains more number of hydrogens here. See, CH2Vr means here is only one carbon, and to this carbon two hydrogens are attached. So if such type of condition, peroxide, how to identify peroxide? Two oxygens are there continuously. See, ROOR, this is called as organic peroxide. It may be hydrogen peroxide, it may be benzoyl peroxide, it may be uh, different peroxides are there. Sodium peroxide is also there. So if the peroxide, you should identify the peroxide. This is a two double bonds are continuously joined. So it is very easy to identify the peroxides. Then solve these examples at your home. These examples are depending on the Markovnikov's rule or peroxide effect. I will explain this only one example. See what is given. Write the IUPAC names of the products obtained by the addition of HBr to hex 1 in. Hex 1 in, you have to identify hex 1 in means this is alkene, and on the carbon number 1 there is a double bond. So here, see in the solution, this is hex 1 in. 1, 2, 3, 4, 5, 6. 6 carbons are there, and double bond is there on the carbon number 1. So we have to add HBr to this hexene, and number 1 condition is there in the absence of peroxide. In the absence of peroxide, and second condition is there in the presence of peroxide. So this second example is in presence of peroxide, and we will discuss here no peroxide is added. So if no peroxide is added, always the addition takes place according to the Markovnikov's rule. Means this negative part we have to check first. So in this HBr, this Br is negative. So this Br will gets attached to the carbon atom. Now we have to check the double bonded carbon. This carbon having the double bond, this carbon having the two hydrogens, and this second carbon having the only one hydrogen. So Br is preferably gets attached to the carbon number 2 according to the Markovnikov's rule, because here is only one hydrogen and there are two hydrogens. So we get here 2 bromohexene, only one product here. Means this is the major product. But less amount of product is also formed when Br is gets attached to the carbon number 1. But its percentage is very less. So 2 bromohexane, it is the major product. And in case of peroxide, see, this negative parts get attached to this carbon number 1, because addition takes place according to the anti-Markovnikov's addition here. We can clearly see the difference between these two examples when peroxide is added and there is no peroxide. So this is the main difference of Markovnikov's rule and anti-Markovnikov's rule in absence of peroxide, in presence of peroxide. Now the next fourth reaction is addition of sulfuric acid. All of you know sulfuric acid, it is having the molecular formula H2SO4. This H2SO4 can be written like this. This is H is separated. HOSO3H. HOSO3H. So this H2SO4, for the addition purpose, it is written separately. First, see how the reaction takes place. Alkenes, so this is general alkene is taken, reacts with cold concentrated sulfuric acid. So it is a cold concentrated sulfuric acid. So again, this is the negative part, hydrogen is positive part. So here there is a no problem of symmetrical alkene and unsymmetrical alkene, because this alkene is symmetrical. That's why it is shown hydrogen gets attached to this carbon, and OSO3H. This is another group which is attached to the second carbon, and we get this compound. This compound is called as alkyl hydrogen sulfate, because this group is alkyl. This is a hydrogen and this is a sulfate. So it is called as alkyl hydrogen sulfate. See, the one example is shown here, ethene plus H2SO4. Hydrogen gets added to this carbon or this carbon, because this is symmetrical. So there is no question of less hydrogens and more hydrogens. So hydrogen can be added here to this carbon or this carbon. If hydrogen is added to the second carbon, the OSO3H group will be attached to first carbon. See the name of this compound, ethyl hydrogen sulfate, because we taken here ethene. If you taken here propene, it will be propyl hydrogen sulfate. If you take butene here, the name of the compound will be butyl hydrogen sulfate. So according to the alkene, its name will be changed. This is for symmetrical alkene. Now I am coming to the unsymmetrical alkene. I will give you one example of unsymmetrical alkene. See, this example is unsymmetrical alkene. How to check? See, this is a carbon-carbon double bond, so only two hydrogens are there, and here another one CH3 group is attached. Means to this carbon-carbon double bond, the condition is not symmetrical. This is a heavier group or bulkier group. So in this case, what is happening? It is given, it is mentioned in the reaction. The addition takes place according to the Makovnikovs rule. We will check. See. So H2SO4, hydrogen and OSO3H group. See, OSO3H groups gets attached to the carbon atom which is having the less number of hydrogens. Here we can see clearly only one hydrogen is there, and hydrogen is added here. Hydrogen will be added to this carbon, so it becomes CH3. It becomes CH3 and hydrogen will be added and the second carbon. So if this is a isopropyl hydrogen sulfate, isopropyl hydrogen sulfate, this compound is called as isopropyl hydrogen sulfate. When this undergoes hydrolysis, means if the water is added and it is heated, it gets converted into alcohol. See, this group CH3 as it is, this CH3 will be as it is, and this group OSO3H group will be converted into alcohol, and again we will get back the H2SO4. Again we will get back to the H2SO4. So here is also another example. This is ethyl hydrogen sulfate. If it is undergoes hydrolysis, we will get either ethyl alcohol or it is called as ethanol, and again H2SO4 will be regenerated. H2SO4 will be regenerated. So this is a very important reaction for the excellent method for preparation of large scale of manufacture of alcohols. Alcohols preparation करने के लिए this method का use करते हैं. Then next one, number 5 is addition of water. All these reactions we are discussing reactions of alkenes. So here one example of alkene is taken. See the name of this alkene, 2-methyl propionine. Prop indicates three carbons, 1, 2, 3, and second carbon. See, this is the second carbon having the CH3 group. So it is 2-methyl propionine. Vanine indicates on the carbon number 1, that is a double bond. So addition of hydrogen, again, addition of hydrogen always takes place according to the Makownikoffs rule. Hydrogen, single hydrogen having the plus charge and this OH having the negative charge. So according to the rule, OH gets attached to the carbon atom which is having less number of hydrogens. So in case of this 2-methyl propionine, this carbon, see, this carbon do not having any hydrogen, but this carbon having the two hydrogens here. So this OH group gets attached to the carbon atom to which CH3 groups is there, two CH3 groups. See, two CH3 group आहेत, याच्याकडे एक पण हायड्रोजन नाहीये, इथे बघा याच्याकडे दोन हायड्रोजन आहेत सेकंड कार्बनला. So according to the definition of Markovnikov's rule, this OH will be attached to this carbon. या कार्बनला इथे OH attached. See, इथं आपण see in the product it is already shown. कुणाचं तरी माईक सुरू आहे. यश कडू, mute yourself. So this 2-methyl propionine gets converted into alcohol. Addition of water, this reaction is also called as hydration of alkenes. Hydration म्हणजे पाणी, addition of water, it is called as hydration. Remember, addition of water to alkene, it is called as hydration of alkenes. म्हणजे याच्यामध्ये पाणी ऍड करायचं, वॉटर ऍड करायचं म्हणजे हायड्रोजन आणि OH कुठल्या पोझिशनला जॉईन होतात बघा. Next, number 6 reaction is ozonolysis. This is the addition of ozone in alkenes. This is called as ozonolysis of alkenes. It is nothing but addition of ozone. Addition of ozone takes place in the presence of inert solvent. We can take here inert solvent, means that solvent should not react with alkene. It is called as inert solvent. We can take here carbon tetrachloride, or we can take here hexene also. Hexene is also acts as a solvent. So here in this example, CCl4 is taken. CCl4, it is nothing but carbon tetrachloride. We can see here 4 chlorine atoms are attached to only one carbon. This is called as carbon tetrachloride. So first step is alkyl ozonide is formed. In the first step, alkyl ozonide is formed, means these three oxygens are gets attached to this double bond. This double bond, it will be broken, and we get here first oxygen is added here, then second oxygen, and third oxygen. This is a temple-like structure. Remember, this reaction is very, very important, and it is quite very difficult to understand. So when the regular college will be started, again I will explain on the board also, but try to understand on the online mode. It is very difficult to explain how this oxygens will be added. So O3 means three oxygens, it is ozone. So we can see here first oxygen is added here, this is second oxygen, and this is the third oxygen. So this ozonide, it will be broken, this ozonide will be broken in presence of zinc dust. Zinc dust, it is used for the breaking of this ozonide. Remember, zinc dust in presence of water, it is used to break this. Zinc dust, actually it is used as a reducing agent. It will so this bond will be broken like this way and this way. I will show with the help of this arrows. See, so this bond will be broken like this way, like this way. Means this oxygen will be completely removed, and we get here two carbonyl compounds. This is the first carbonyl compound, and this is the second carbonyl compound. So this is a very good method, and this zinc O means this zinc dust pick up this single hydrogen, and we get here zinc oxide. We get here zinc oxide as a byproduct. This is a byproduct, and main products are carbonyl compounds. So by this alkene, we can prepare aldehydes and ketones. See, one example is given here. If ethane is taken and ozone is added, So here the breaking is shown. See, so as per this general reaction, first oxygen is added here, then second oxygen, third oxygen. So we will break this ozonide like this. See, we will break like this. So zinc is used for the breaking of this ozonide, zinc dust. The role of zinc dust is to break this ozonide, and we get here first one. What is the, anyone can tell me the name of IUPAC name of this compound? Because the common name is already given below. The common name is, this is one molecule of formaldehyde, this is another molecule of formaldehyde, and this is zinc oxide. So I want the IUPAC name of this compound, formaldehyde. So anyone can tell me? 58 students are there. Out of 58 students, anyone can tell me? This is aldehyde having the only one carbon. So already I taught in the class, when the aldehydes having only one carbon, what is the name? Yes, anyone? कुणी पण एकाने सांगा.
मिथाइलडिहाइड.
आपण असं मिथाईल शब्द वापरतो का? आपण अल्डिहाइडचं नाव कसं देतो? एनीवन? माळी आहे का?
मिथेनॉल्डिहाइड.
नाही. आर्य का? आर्य ठाणेकर?
मिथेनॉल.
कोणी सांगितलं? इशिता. आवाज येतोय का रे माझा तुम्हाला?
Yes, sir. Yes.
Acetal aldehyde.
Yes, sir.
आता येतोय का?
येतोय.
हा, बरोबर सांगितलंय. When there is only one carbon in the aldehyde, it is called as methanol. When two carbons, ethanol, then propanol, pentanol, hexanol. म्हणजे तुम्ही वाचत नाहीये, लक्षात घ्या, मला कळतंय. Daily revise the functional group chart. then the organic chemistry will be very easy. Otherwise, it will be difficult. So, the two molecules of formaldehydes, the IUPAC name is methanol. Now, if I want to prepare here ketones, this is a very important question I'm asking to you. I want two molecules of ketones, means two molecules of here acetones. Instead of this hydrogen, I want CH3. Instead of this hydrogen, also I want CH3 group. Instead of this hydrogen, also I want CH3 group. And instead of this hydrogen, also I want CH3 groups. So, which changes I have to make here? This hydrogen will be replaced with CH3. This hydrogen I have to make change with CH3 group. This hydrogen also I have to change with CH3 group. And this hydrogen also I have to change with CH3 group. If all these hydrogen become CH3, then I will get here two molecules of ketones. So if there are 1, 2, 3, 4 methyl groups are there, then tell me the name of this alkene. This is my question to all. Means you understand? CH3, CH3, then C.
Tetramethyl ethene.
IUPAC सांगतोय का कॉमन नेम? इकडे बघा मी स्ट्रक्चर इथं काढायचा प्रयत्न करतोय. इट इज व्हेरी डिफिकल्ट टू ड्रॉ फॉर मी because I am using that single dot. Again here CH3 here दिसते का छोट्या मुलासारखं अक्षरी because I am drawing with the help of mouse. See, this is yes. So rules, we have to remember the rules. What are the IUPAC rules? Select this longest chain. Yes, कोणी सांगितलं होतं ना? आता नाव सांगा मला. Tell me the name. तुमच्या समोर चेन आहे. चेन मध्ये 4 कार्बन आहेत. Second carbon having the double bond, also second and third carbon having the CH2 group. So tell me the name.
2,3-dimethyl butane.
Very good. 2,3-dimethyl
Butane.
butane का butene?
2,3
Butane.
Butane.
dimethyl bute twin.
Very good, very good. Say in the longest chain, this is the longest chain. I will show you. See, this is the longest chain. So this is carbon number 1, this is carbon number 2, this is carbon number 3, and this is carbon number 4. Okay. On the second carbon, there is one CH3 group here. On the third carbon, and another CH3 group is there. So if the 4 carbons atom in the chain, it is butene. But second carbon having the double bond, so it is 2-butene. When substituents are attached on the second and third carbon, both the substituents are same. If both the substituents are same, we are using the word di. If the 3 substituents are there, we will use the word tri, like this: di, tri, tetra, then penta. So here, the second carbon and third carbon, the same substituents, methyl groups are there. So the name will be 2, 3, 2, 3 di methyl but 2 in. This is the correct IUPAC name. So if this alkene is used, if it undergoes ozonolysis, we get here 2 molecules of acetone. Make a practice of this reaction. Means examiner for the board examination, examiner can ask like this question: how will you prepare 2 molecules of acetone by using ozonolysis reaction? They will not give this alkene. They will give the product and they will give the name of the reaction, ozone. So we have to prepare the alkene, remember. We have to prepare the alkene. So here I think it is shown. it is shown one, in this example, one molecule of ketone and one molecule of aldehyde is prepared. So this also, there is also possibility of formation of mixture of aldehydes and ketones. See, clearly we can see here, one is, this is ketone and this is aldehyde, this is formaldehyde and this is ketone. Addition takes place here across the double bond. One oxygen is added this above and two oxygens are added below. It is not actually above and below, but for your understanding, I am showing. This is a, if it is three-dimensional, all the oxygens are in the same plane. Then number 7 reaction is hydroboration of, it is also called as oxidation of alkene. This reaction, last time it is included in the 11th standard. Before that, this reaction was in 12th standard. So this is very easy to understand. I have given this reaction in very simple steps. So I request all the students, don't go to the textbook. If you go to the textbook, you will get confused. So I have make this reaction in very simple steps. I will explain. So hydroboration means what? I will explain first. Hydroboration means the addition of diborane. Diborane, it is a compound having the formula B2H6 here. Capital B indicates it is boron. B2H6. This is called as diborane. Di means two boranes are there. In tetrahydrofuran. Tetrahydrofuran is a solvent. THF. It is short form. Tetrahydrofuran. That is a THF. It is a solvent. So in this solvent, alkenes undergoes hydroboration reaction. Hydro and boration means hydrogen and borons are there. This is a compound of hydrogen and boron. That's why it is called as hydroboration. Diborane, because two boranes are there. To form trialkyl borane. Trialkyl borane. See, इथं बघा, trialkyl. Hey, this is a trialkyl. Trialkyl borane is formed. Means when alkene reacts with diborane, we get the first product is trialkyl borane. I will show with the help of this pen, dot pen. This is a trialkyl borane. This is a trialkyl borane because three, you can clearly see this trialkyl. Any alkyl group is there. It will be depend upon the which alkene is used, and this is borane. So trialkyl borane is the first compound, which on oxidation, see here, oxidation H2O2, this is a hydrogen peroxide, acts as oxidizing agent, which on oxidation with alkaline peroxide. Alkaline means here base is used, that's why it is called as alkaline. If acid is used here, it is called as acidic oxidation, but here base is used. So alkaline peroxide forms primary alcohol. Means what is the final product of this reaction? Primary alcohols are formed. See, this is the primary alcohol. Now you are very well known about the primary alcohol, secondary alcohols, and tertiary alcohols. So how the reaction takes place? First, in the first step, this reaction takes place according to the anti-Markovnikov's rule. Remember, anti-Markovnikov's rule means negative part will be gets attached to the, yes, anyone can tell me the negative part in anti-Markovnikov's rule, the negative part gets attached to the carbon atom which contains more number of hydrogens or less number of hydrogen.
Less number of hydrogens.
Less number.
I am talking about the anti-Markovnikov's rule.
More number of hydrogen.
Yes. अँटी-मार्कोनिकॉफ्स मध्ये ज्या कार्बन कडे जास्त हायड्रोजन असतात तिथं निगेटिव्ह पार्ट अटॅच होतो, लक्षात घ्या. आणि मार्कोनिकॉफ्स मध्ये ज्या हायड्रोजनला ज्या कार्बन कडे कमी हायड्रोजन आहे तिथे निगेटिव्ह पार्ट जोडला जातो किंवा अटॅच होतो. हे दोन एक्झाम्पल मी परत एकदा तुम्हाला दाखवतो, आता कन्फ्यूज करायचं नाही. मार्कोनिकॉफ्स आणि अँटी मार्कोनिकॉफ्स मध्ये बघा, इथे बघा, दिस इज अ मार्कोनिकॉफ 40. हा ब्रोमिन कुठं जोडलेला आहे? सेकंड कार्बनला. कारण इथं सेकंड कार्बनला किती हायड्रोजन आहे? तिथे इथे एकच हायड्रोजन, म्हणून हा ब्रोमीन इथे जोडलेला आहे. आणि अँटी मार्कोनिकॉफ्स ऍडिशन मध्ये बघा तुम्ही इथं, हा, in anti-Markovnikov's addition it is takes place only in presence of peroxide. इथे बघा, आता इथे 2 हायड्रोजन आहेत आणि इथे 1 हायड्रोजन. So this bromine gets attached to carbon number 1 here. कार्बन नंबर 1 ला ब्रोमीन इथे जोडलेला दिसतोय, because see, yeah, see this carbon having the 2 hydrogen and this carbon having the only 1 hydrogen, and see this bromine gets attached to this carbon which contains more number of hydrogen. So this is according to the anti-Markovnikov's addition. हे लक्षात घ्या. So this hydroboration reaction also takes place according to the anti-Markovnikov's addition. आता इथे 2 पार्ट केलेले आहेत, हायड्रोजन अँड BH2. So this is a negative part and this is a positive part. म्हणजे हा हायड्रोजन कुठे जोडला जाईल? This hydrogen gets attached to this carbon and this BH2 gets attached to the first carbon because this is a negative group. इथे बघा, इथे जोडून दाखवले हायड्रोजन अँड BH2. अँटी मार्कोनिकॉफ्स ऍडिशन खूप महत्वाची गोष्ट आहे. हायड्रोबोरेशन मेनी टाइम्स इट इज आस्क्ड फॉर नीट एक्झाम, जेई एक्झाम, सीईटी एक्झाम. प्रत्येक एक्झामला हायड्रोबोरेशन वर प्रश्न असतो. Hydroboration takes place according to the which rule? So remember this addition, anti-Markovnikov's addition. So this is the first product. Again, one alkene is added. We get here 2 molecules of alkene. एक हायड्रोजन यातला कमी होतो अजून बघा. BH2 मधला एक हायड्रोजन कमी झाला. अगेन एक 1 molecule is added, alkene. So तिन्ही पण इथले BH2 मधले दोन्ही पण हायड्रोजन गेले आणि नुसतं ब्रोमीन राहिलं इथे. So what is the name of this compound? Trialkyl borane. Now this trialkyl borane undergoes oxidation. So this is oxidizing agent H2O2 in presence of alkali, and we get here OH, and this is a byproduct. This is a byproduct is formed. So this is one of the method of preparation of alcohol. In 12th standard also this method is given in the chapter alcohols. Now the number 8 reaction is polymerization. After completion of time, again we have to join with the same link. So my timer is showing only the 2 minutes are remaining. After 2 minutes, again we have to click on the same link and we will continue. Polymerization. Polymerization, it is a process actually. Polymerization means it is a process of preparation of polymers. Polymers म्हणजे काय सांगतो? Polymers means these are the very long chain compounds. Long chain compounds means they contains 100 carbons, 200, 300, 400, 500. These are the very bulkier and having the very large molecular weight compounds. त्याला म्हणायचं पॉलिमर. फॉर एक्झाम्पल तुम्हाला सांगतो, इन अवर डे टू डे लाईफ वी आर युजिंग डिफरंट पॉलिमर्स. Polythene bottle, that bottles are soft drink bottles, then polythene bottles, your compact disc, then your clothes, polyester, then your slippers, all these materials, your carbon cover of the your telephone, that is cell phone, it is made up of with polycarbonate. All these materials, it is prepared with polymers. Means these are the chemical compounds which are long chain compounds having the very high molecular weight. It is called as polymers. And the method of preparation of polymers, it is called as polymerization. In 12th standard, one chapter is there, Introduction to the Polymers, chapter number 15 in 12th standard. We will understand what is meant by polymerization. So in 11th standard, only the introduction is there. The process in which large number of small molecules, that small molecules are called as monomers. So monomer is a small unit and polymer is a bigger unit. So many monomers combined together, joined together, and a very large molecule is formed. That is called as polymer, and the process is called as polymerization. The process is called as polymerization. So it is mentioned the compound having very large molecules made up of with repeating units, it is called as polymer, and the simple unit it is called as monomer. Monomer is the smallest unit of polymer. So here see ethene.